Okay, we're doing 4-1 and 4-2. Okay, 4-1 is called integers as exponents. Oops. Ooh, that's big, huh? Huge. Integers as exponents. You already know, like, positive exponents, like 2 to the third power means 2 times 2 times 2, right? Okay, that's not focusing very good. Okay, now if you have a negative exponent, 2 to the negative 3 power, that means 2 to the third power is on the bottom, okay? Means 1 over 2 to the third power. So if 2 to the third power is 8, 2 to the negative third power would be 1 over 8. Okay? Okay, let's say we were multiplying 2 to the second power times 2 to the third power. Okay, you've already seen something like this, right? This would be 2 of them and then 3 of them. Oops, that's another 2. Okay, 2 2's and then 3 2's is 5 2's, right? Be 2 to the 5th power. So if they're multiplied like that, you just add the exponents. Keep the 2, keep the base, and add the exponent. So it's 2 to the 5th. Okay? So let's say you have 4 to the second power times 4 to the 8th power. What is that? 4 to the 10th power. Okay? Just add the exponents. Let's say we have one of these would be a negative. Let's say 4 to the second power times 4 to the negative 8. You're going to add 2 plus negative 8. Okay, so that would be 4 to the negative 6 power. Okay? If you divide, let's say you have a fraction with exponents. Let's say you have 4 to the 5th power over 4 to the 3rd power. Okay, think of this as like 4, 5 times on top, 3 times on bottom. Okay, if you cancel, divided by 4 3 times, you would still have 4 2 times on top, right? Okay, so what would you do with these numbers here to get that? Subtract. You do the top minus the bottom. Okay, so you could look at this as 4 to the 5 minus 3 also. The top minus the bottom, 5 minus 3. Okay, look at this one that we did before here. 4 to the 2 times 4 to the negative 8. Okay, let's go up here just a little bit. Okay, remember when we said a negative was like it was on the bottom? This one right here, 2 to the negative 3 is the same as 2 to the 3rd being on the bottom here. Okay, let's look at this one right here using that concept. Okay, let's say the 4 to the 2 times 1 over 4 to the 8. Okay, that puts our 8 on bottom. That'd be like 4 to the 2 over 4 to the 8. Remember we said we do the top minus the bottom? 4 to the 2 minus 8. See, 2 minus 8, you're still going to get 4 to the negative 6. So let's write down some simple rules here. If we're multiplying, what do we do with the exponents? Add. Okay. So if you're multiplying exponentials, you're going to add the exponents, right? You can't see it, it's too little. Multiplying exponentials, you add the exponents. You're going to keep the base though, right? Make sure you keep the base and don't do anything with it. That bottom number, keep the base. Okay, dividing. You're going to do what with the exponents? Subtract, remember? Top minus bottom. Okay, let's say we have more than just one number in our, let's say we have 4x to the second power over 4x to the fifth power. What is our base on that one? What's being taken to the power? 4x. This is our base. So you keep the base. Keep it in parentheses, because if you just put the exponents up here, they're only going to the x. In parentheses, it goes to the whole thing. So it's 4x to the 2 minus 5, right? Which simplifies into 4x to the what?
Negative 6.
Negative what? Oh, 3. Negative 3. Okay, let's spread some variables out here. Let's go p to the 3 q2 over q p to the 4. Okay, you could do the p's together and the q's together. So do p to the 3. Since it's over 4, put minus 4. And then the q will be to the 2 minus 1. If there's not anything there, it's a 1, right? So the p is 3 minus 4, negative 1. The q is 2 minus 1 is 1. So it could be written like this, or if it's negative, it could be on bottom, right? You could change this to, you could leave the q1 on top and put this negative 1 on the bottom. To get rid of the negative sign, you just put it on bottom. Let's see, what if you had a negative on the bottom? Let's have a p to the negative 7 on bottom and p to the negative 6 on top. There's two ways you could do this one, okay? You can either go p to the negative 6 minus negative 7, and then change the minus negative to plus positive, right? So it'd be p negative 6 plus 7 would be p to the 1, or just p, right? Or if you'd like to get rid of the negatives first, I like to get rid of negatives. It makes it simpler, okay? If you take the p to the negative 7 to the top, it makes it p7 on top. The negative 6, if we take it to the bottom, it'll be positive. Okay? So if you switch it to the other side, it turns to a positive exponent. And now this is easier. P to the 7 minus 6, top minus bottom, is just P to the 1. So if you just switch it, it'll be easier. I think it'll be easier. You can do it either way though. Okay, let's say you have Q to the 5 over Q to the negative 4. Okay, you can either do the subtraction, do 5 minus negative 4, or you can bring this up as Q4 on top. And now that they're both on top, they're just multiplied. So it would be Q5 plus 4, which is Q to the 9th. Which would have came out the same if you would have did Q to the 5 minus negative 4. It would have came out the same. But I like to make it positive and just work with positive numbers. Okay, what if we had P to the 4 over P to the 4? Huh?
It would just be 1.
It's just 1. It's P to the 4 minus 4, which is P to the 0. Anything to the 0 is 1. You see why? Because if it's the same on top and bottom, it's going to be 4 minus 4, which is a 0 in your exponent. That means you have the same thing on top as you have on bottom. So if it comes out to something with a 0 power, you know it's a 1. Okay, so that's pretty much what you're going to be doing on 4.1. Look it over, see if you have any questions. You'll probably want to go ahead and do all of 111 and 112. 111 is optional, but that gives you all the different ways you could do the 1 over 5 and 5 over 1. That way you can check in the back of the book and make sure you're doing it right. Because 111 is odd, and it'll be in the back of the book. On page 316. Okay, there's a little bit of skills maintenance, the sum of the page numbers on facing pages of a book. Let's go over that real quick before we go into 4.2. That was one of the things that was on the test. Some people got it, some people didn't. The sum of, let's do something other than the one that's right here. Let's say the sum of 2 page numbers is 2 facing page numbers, okay? That means they're consecutive, right? Is 113. Okay, what are the page numbers? Okay, one page number would be like X is your first page number, right? The next page number is going to be 1 more. So your second page will be X plus 1. So you have X plus 1. Those 2 page numbers add up to 113. Okay, if you had 3 consecutive, you'd have an X plus 2 also, right? Okay, this is only 2 page numbers. X plus X is 2X, plus 1 is 113. So subtract 1, 2X equals 112. Divide that by 2. X equals 56. So the page numbers are 56 and 57. Oops. I was thinking 7 already. 57. Okay? So that's the way it wants you to do it for the consecutive page numbers, not just dividing by 2 or 3 or something, okay? That's what it's wanting you to do. And how many angles in a triangle?
3,
They add up to,
180.
yeah, the 3 angles add up to 180. So you need that for part of your skills maintenance also. Okay, the next section is scientific notation. And the reason it's called scientific notation is because it's used for very large and very small numbers. Okay? Scientific. It's used for like microscopic, tiny, tiny numbers, like 0.000000412. Instead of writing it like this, you would write it with one number in front of your decimal, a non-zero number, and then you'd say times 10 to a power. Okay, this power will be negative for small numbers. Okay? This is going to be a negative for this number. For large numbers, it's positive. Okay, this tells you how far you moved your decimal. Okay? It's 1, 2, 3, 4, 5, 6. So that number is 4.12 times 10 to the negative 6. If you went out into space and you were talking about a huge number like this, instead of writing that number every time, it would be easier to write it in scientific notation. You'd write still one number in front, so it looks a lot like that number, but they're very different, right? These two numbers are very, very different. Okay, this one is going to be times 10 to a positive power. 3, 6, 9, 12, 15, 16, 17 to get right there, to the 17th power. Okay? So if you remember the really large numbers are positive and the small numbers are negative, that'll help you to remember how to do that. Okay. You're not only doing scientific notation in this though, you're also doing multiplying. If you have like an exponent, like 2 to the 3rd power raised to an exponent, that means you're doing 2 to the 3rd 5 times, right? Okay. Instead of doing it 5 times, there's an easier way. Okay, instead of doing this, which would be 3 plus 3 plus 3, that would end up being 15. What's easier than that? If you multiply these two numbers, you get 15, right? So just do 2 to the 3 times 5 instead of this. It's the same thing as doing this, but this is easier. So it's 2 to the 15th power. Okay, let's say you have two numbers in here, like you have x, y to the 3rd power, and then you're raising it to the 7th power. You have to do this multiplied by every exponent, okay? You have to do it times the one that's not there, which would be a 1. So the x would be to the 7th power, and the y would be to the 21st power. Okay? Even if there's a number in there, so you have 2 to the 2ab squared, and all of this is to the 4th power. Every one of these have to be raised to the 4th power. You have to multiply 4 times all those exponents. So 2 to the 4th power, a to the 4th power, And then B, what? 8, right? 2 times 4. 2 to the 4th power. I think when you have numbers, they're going to want you to go ahead and do the multiplying. The answers that I see show that they've been raised to the power. So you're going to have to do this 2 times 2 times 2 times 2, which is 4 times 4 is 16. A to the 4th, B to the 8th. That's not equals, I'm sorry. It's just 16, A to the 4th, B to the 8th. Okay? Let's say you have a negative inside the parentheses. Let's say we have 4 out here. Inside here we have negative A to the 3rd power, B to the 4th, and we have an exponent up here of 3. Okay, the one on the outside does not get taken to the power. Leave that number, okay? The 4 stays out here. This negative out here is like negative 1. So negative 1 to the 3rd power. And then A to the 3 times 3, which would be 9, right? And then B to the 4 times 3. So we have 4. Negative 1 to the 3rd power is what? It's going to be negative, right? There's negative times negative times negative is 3 negatives. So this is negative, and then 1 times 1 times 1 is 1. So this is negative 1. So negative 1 times 4 will be making it into a negative. A to the 3 times 3 is 9. B to the 4 times 3 is 12. Okay, now let's do some with negative exponents. Okay, all of those to the negative 2. Let's go ahead and multiply negative 2 times every exponent. 2 times negative 2, negative 4, right? This would be B1. 1 times negative 2 is negative 2. And then C to the negative 2 would be just C negative 2. The D is 3 times negative 2. 3 times negative 2 is negative 6. Okay. If it tells you to simplify and put everything with positive exponents, to make all these positive, anywhere there's a negative, you take it to the other side. So you take both of these to the bottom to make them positive. You take these to the top to make them positive. And that would be the answer with positives. Sometimes you see problems that say, make this into a positive exponent or make this into a negative exponent. So all you gotta do is switch the side. Okay, let's do some scientific notation where we are changing it from the scientific notation back to the number, and then we'll do some multiplying and dividing scientific notation. Okay, if you have this number 9.07 times 10 to the 6th power. Okay, is this one going to be a big number or a small number? Big number. This was how many times we moved the decimal, right? So we're going to move the decimal back to get it to the original number. It started here. Let's go ahead and put our numbers. Then we're going to move it 6 times. 1, 2, 3, 4, 5, 6. You have to add 4 zeros. Now go back into that number and put your commas. So it's 9,070,000. 9,070,000, right? Let's do the same number with the negative exponent. -3. Small or big? Small number. How many times are we going to move it? 3 times, right? So put our 907, put it off to the side because we have room to move your decimal forward, okay? Or I'm not going to say forward and backwards because people use those terms differently. I would call this forward. Some people call that forward. So let's say to the left, okay? So it was right here. We'll move it to the left now. Make it a smaller number. 1, 2, 3. From here, 1, 2, 3. That's where our new decimal is. If it starts with a decimal, what do? Add a 0 to the front. So 0.00907, right? Okay, now let's change. Let's go like we're multiplying. If we had 2 numbers like 3 times 10 to the 5th power times 2 times 10 to the 3rd power. This would be like 300,000 times 2,000. Instead of doing it like that, it's easier to do it like with it like this. You just do the 3 times 2, and you get 6. What did we do when we multiplied? We had like bases. You add the exponents, right? So you have 10 to the 5 times 10 to the 3rd power. 10 to the 5 plus 3 is 8. So that's your answer right there. Let's do some that get a little bit harder though. Let's do like 5.2 times 10 to the 5th. Multiply it by 6.5 times 10 to the -2. What do you get when you multiply 5.2 times 6.5? Anybody? Is it 33.8? Somebody do it real quick on the calculator. Is it 33.8? Okay. Now 10 to the 5 times 10 to the -2. We're going to do 5 plus -2, right? We add those two. 5 plus -2 is what? Is +3. Okay, when you do this, and they're both scientific notation, you need to get an answer in scientific notation. A 33 in front of a decimal is not scientific notation. One number in front of the decimal is scientific. Or one number right here, you should only have one number before the decimal. So this should be 3.38, but since we moved our decimal, it changes our exponent. Okay, remember with bigger numbers, when we made them scientific, like the big numbers, we moved them back this way. We added that many up here. The smaller numbers, when we moved it that way, we went negative. Since we're moving our decimal to the left, are we gonna be adding or subtracting? This way we moved it to the left. We're gonna be adding, right? This is a bigger number, so it's positive, we would be adding. So instead of a 3, we have a 4 here. We added 1 there, and it made it 4. We moved it one time to the left, and we added 1. Let's do another one of those. 9.9 times 10 to the negative 6 times 8.23 times 10 to the negative 8. Multiply these two numbers, what do you get? $81.477. Okay, and then when you multiply the two tens, you're going to add the exponents, right? What is a negative 6 plus a negative 8? Negative 14. Okay, how are we going to make this scientific notation? Moving it one time to the right, or to the left, I'm sorry. Moving it to the left once. So you have to add 1 to this, right? So what does it make it? Negative 13. Sorry. Okay, now let's do one where it's division, where it's a fraction. Like 4.1 times 10 to the negative 3rd power over 8.0 times 10 to the 20th power. Okay. If you divided those, what would you get? 4 divided by 8. Get a half or 0.5, right? We'll do the decimal part because we're doing scientific notation. We need decimals. Okay. Then what do you do when it's a fraction? Subtract. You subtract. You do the top one minus the bottom one. So we have 0.5 times 10 to the what? Negative 23rd. How are we going to make that scientific notation? We have to move it the other way, right? When we moved it to the left, we added. So if we move it to the right, we're going to be subtracting 1. You subtract how many you move it. We only have to move it 1. So subtract 1 from it. This is 5.0 or just 5 times 10 to the what? Negative 24. Okay, let's do one more fraction one, and then I think you'll be able to do the rest. We'll see. One more fraction. 1.5 times 10 to the negative 3 over 1.6 times 10 to the negative 6. Okay, what do you get when you have 1.5 divided by 1.6?
0.9375.
0.9375. The tens, we're going to have the negative 3 minus the negative 6. Right? Which is plus positive, right? Minus negative, turn that into plus positive. Okay? So now I have negative 3 plus 6. What's negative 3 plus 6? Positive 3. Okay. Now we're going to have to move that to get it scientific. To the right, which adds or subtracts? It subtracts 1, right? So you have 9.375 times 10 to the 3 minus 1 is 2. Now it's scientific. Look at the problems if you have any questions. On number 90, it says that you have 2,500 gigabytes of memory. If you have that many gigabytes of memory, how many bytes are in the network? 1 gigabyte's about 1,000,000. Okay, it says that. It says there's 2,500 gigabytes, right? This is supposed to be the same as 1,000,000,000. A gigabyte's 1,000,000,000. So you have 2,500 billions. Okay, think of this as if this was just 1 billion. That would be billions. That would be your millions, thousands, and then your hundreds, right? So you can either add the 9 zeros, or it tells you here 1 billion is 10 to the 9th power. So you could do the 2,500 times 10 to the 9th power. But neither one of those is scientific notation, are they? Okay, to turn it to scientific notation, you need one number in front of the decimal, right? So you'll need 2.5. You won't need any of these other zeros. Okay, you can either move your decimal on this one. If you added the zeros, you could move your decimal on that one. And that would be positive because it's a huge number, right? Or you can move it back on this one and add it to this exponent. So you're either going to go 3, 6, 9, 10, 11, 12 here. Or you're going to go 1, 2, 1, 2, 3 and add it to this. Either way, you're going to have a 12, right? That's one of your homework problems right there. I'm going to do one skills maintenance, but not one of the ones that you had for homework. You're doing 102 and 104. I'm going to do number 103. Eight parentheses 2x plus 3 minus 2 parentheses x minus 5 minus, no, equals 10. First thing you do is what? You have your solving equation sheet. Get rid of the parentheses first. We're going to distribute that number on the outside through. 8 times 2x, 16x. 8 times 3, 24. Negative 2 times x is minus 2x. This is where a lot of people make mistakes right here. Negative 2 times negative 5 plus 10. Okay. You don't have any thing on the other side over here to combine, but you have x's here you can combine. 16 minus 2, 14x, and the numbers, 24 is 34, right? 24 plus 10 is 34. Now what's the next step? Subtract 34 from both sides. 10 minus 34. Sign the larger, subtract the numbers. Negative 24. Divide by 14. And it doesn't come out even, but you can reduce it. What can you divide by? 2. We'll get 12 and 7. Can we reduce that? Not really, huh? You could leave it like that, or you could put negative 1 and 5/7. So that's a lot like number 104. Is there any questions on any of the other homework problems?